Now let's talk about chemical bonds. Chemical bonds are from the sharing of electrons. Now let's go back to a previous concept. We said that electrons can do what with an atom? Well, an atom can lose an electron, right? We said that an atom can take on an electron. And we also said that an atom can share electrons. Chemical bonds are from the sharing of electrons. So a covalent bond is made when two atoms share electrons. So here we have what we call molecular hydrogen or diatomic hydrogen. You don't need to remember the specific name, but do you see how we have these two spheres here and here? Those are representing electrons. If we could follow the motion of this, these two electrons would be shared between these two atoms. So one atom does not have exclusive right to those electrons, rather those electrons are shared. Okay? This is a covalent bond. Now you see the little line right here, we draw right here, and we're going to see this line many times during the semester. That represents a covalent bond. The H here and the H here, those are the atoms, and the line between them, this horizontal line, indicates that they're sharing electrons. And that sharing is a covalent bond. Another example, molecular oxygen. This is the oxygen that we are breathing right now that's coming into us and working as what we call a terminal electron acceptor. Do you see how we have two bonds here, two horizontal lines? This means that we have two covalent bonds between these, in which case they are sharing 4 electrons. So this is an oxygen, this is an oxygen, and they're both sharing these electrons between them. All right, so if we could follow just this electron, it would go around this oxygen and this oxygen and this oxygen and this oxygen. None of these oxygens have an exclusive right to those shared electrons. They are shared between the two atoms. Another example of covalent bonds, and this is with water. In the center, what is water? Water is H2O, right? So here we have an H, and here we have a hydrogen atom, and here we have an oxygen atom. And you'll see it drawn this way many times, or shown right here, an HO and an H. Hydrogen, do you see how we have one line here and one line here? That means that the hydrogen and oxygen are sharing 2 electrons. On the other part of oxygen, another hydrogen and that same oxygen are sharing 2 electrons. Again, these electron sharings are what we call a covalent bond. They are sharing the electrons. So electronegativity is the measure of an atom's ability to pull or hold on to electrons from another atom. Okay? And a way to think about this is if something is more electronegative, it's more of a hog of electrons. What do I mean by that? Well, I'm going to use 2 letters here. I'm going to say A and A. And I'm saying these are 2 different atoms. And this one on the left has a higher electronegativity. So I'm going to put an upper and an EN. Okay. The atom on the right has a lower electronegativity. If something has a high electronegativity, it's going to hold on to those electrons. So let's say these are sharing electrons. If the one on the left can hold on to those electrons, remember electrons are in motion, right? Well, it's in motion, but this atom on the left is going to hold on to that electron, even though it's in motion, for a longer period of time. And then it'll go around the right atom. And that electron then comes back to the left, and it's just staying around the left atom. That goes back to the right atom really fast. Right? Left, 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 and it's staying on the atom on the left, and it goes to the right. All right, so what's the point of this? Well, we'll describe the consequences of this later, but this causes a polar bond to form. And we'll talk more about that in a few minutes. But for now, let's just say electronegativity is the measure of an atom's ability to hold on to electrons. If it has a high electronegativity, it's going to hold on to those electrons more or for a longer period of time when it shares them. Now, a non-covalent bond is formed when atoms share electrons equally. So let's say we have two oxygen atoms right here. Okay, each of these are electronegative, but one is not more electronegative than the other. They're balanced. So in this situation, our electrons are shared for an equal amount of time. Because of this, they kind of balance each other out. There's like a balancing of yin and yang. The center of the oxygen has all those protons and it's positive. Okay? And the electrons, which are negative, are shared equally between the two. Okay? And it will balance each other out. And because it balances each other out, neither side becomes any more or less negative. Okay? This is a non-polar covalent bond. The electrons between the atoms are equally shared because the electronegativity of the atoms are the same. One does not hold on or hog the electrons more than the other one. Okay? Think of it as two identical twins that are both really strong and they're pulling. Who's going to win that tug of war? Well, no one really, because they're both strong, sure. But if they're both pulling with the same force, right? No one's going to win. It'll be a draw. Same thing here, that the atoms here have the same electronegativity. They're going to hold on to that electron for the same amount of time, and neither side of the bond will have an advantage. Because of that, no charge forms on either of the atoms. Okay, I think this will make more sense when we talk about what a polar covalent bond is. Now, a polar covalent bond is one where one has more electronegativity than the other one. Okay, so here we have something like oxygen and hydrogen. Okay, and the electron will stay around oxygen more than hydrogen. Now let's watch another video to better describe this concept, and we're going to bring back that idea of electronegativity back into the picture to describe this. Now, this electron is going to be shared between our oxygen and our hydrogen. The oxygen is more electronegative than hydrogen. Now, remember from before we said that if something is more electronegative, it has a tendency to hold on to an electron with more affinity. Or as I use the analogy, it hogs an electron. So let me just use this electron here, and I'm just going to follow the path. Okay, so remember electrons are in motion, right? So let's kind of follow the electron motion. So that electron goes around oxygen, and because oxygen is electronegative, it's staying around oxygen a lot more, okay, because it's hogging it. Then it goes around hydrogen really fast, all right? So now that oxygen is more electronegative, it's hogging that electron, good, and goes around hydrogen. Stays around oxygen a little bit longer because it's hogging it, goes around hydrogen. Stays around oxygen more, goes around hydrogen. And what am I trying to show here? And obviously that's an exaggeration. Now, oxygen and hydrogen are sharing an electron. But is that sharing equal? No. That the electron is more around the oxygen than it is around the hydrogen. Now, what charge is an electron? Well, an electron is negative charge, right? So because that electron is more around the oxygen, this side of it, this side here, takes on a more negative charge because that electron is around the oxygen more. Why? Because oxygen is more electronegative. It has a tendency to hold on to that electron more. It doesn't want to share it very well. It's greedy with that electron that it's sharing with hydrogen. Hydrogen is not very electronegative at all. Because that electron is not being shared and is not around the hydrogen very much, the side with the hydrogen takes on a more positive charge as a consequence. Okay? Because this is a partial charge, we're going to use a little symbol called the delta, something like this. And the side that has oxygen will have a partial negative charge. The hydrogen side will have a partial positive charge. And again, this all goes back to the fact that oxygen is more electronegative. Because it's more electronegative, that electron is around the oxygen more, and then it's around the hydrogen a lot less. Because that negatively charged electron is around oxygen more and around hydrogen a lot less, the side with the oxygen, right, the side with the oxygen, that electron is over here more. Because electrons are negatively charged, this side with the oxygen has a partial negative charge. Conversely, that electron is not hanging around hydrogen very much. It's being shared with hydrogen, but it's not an equal sharing. It's because it's an unequal sharing, and it doesn't have that negative species, if you will, around the hydrogen very much, it's going to take on a partial positive charge. Okay? So that's the idea of electronegativity, that certain atoms hog electrons or will hold on to electrons with a longer period than other atoms. Well, before we've described differences in electronegativity. Well, hydrogen bond is an extreme form of that situation. So we have a video following this, but I'll just give a brief description here. So here we have hydrogen, and over here we have, say, an oxygen. And when the electron is around oxygen more, then it goes around hydrogen, stays around oxygen more, goes around hydrogen, right? Because this has a higher amount of electronegativity. It's going to hold on to that electron more. Because of that, it's going to form that partial negative charge. Balances it out. There's no balance here. This is more negatively charged. Consequently, because that electron, which is negative, is not around the hydrogen as much, it takes on a partial positive charge. Now let's bring another molecule over here. Let's say we have an oxygen over here connected with some hydrogens. Okay. Same idea. The electrons are being held around oxygen more because oxygen is more electronegative. They go around hydrogen. Stay around oxygen, go around hydrogen. Staying around oxygen, going around hydrogen. Point is the oxygen will take on a partial negative charge, hydrogen's a partial positive charge. Now what do we have here? We have one that has a positive charge here, right, the hydrogen. Over here we have a partial negative charge. When these two interact, and I'm drawing lines to represent a bond, when these two interact, we have a hydrogen bond. So that bond right there is a hydrogen bond. So let me go to the blackboard and describe this a little bit better for you. Let's just draw our water here, and this is just one example. We have our oxygen, and we have our hydrogen, and we have our hydrogen, right? Okay, H2O. Now, these have a covalent bond between them. They're sharing electrons. And remember we said this sharing was not equal. The electrons are more around the oxygen than the hydrogen because oxygen's more electronegative. And because of that, we said that oxygen took on a partial negative charge and hydrogens took on a partial positive charge, right? And this all goes back to that the sharing of electrons between hydrogen here and oxygen is not equal. Why? Electronegativity. So let's say we have another water molecule over here. What if we had an oxygen over here? We got the same structure, H2O. Okay. And the oxygen right here is a negative, and the hydrogen is a partial positive, and the hydrogen over here is a partial positive. Great. Now, what happens? What do opposites do? Okay, remember the Paula Abdul song, Opposites Attract. Remember that song? Probably not. But opposites attract, right? So we have a negative charge over here, and we're going to have some type of an attractive force between this negatively charged oxygen and the slightly positively charged hydrogen. Over here, we'll have a hydrogen for water. Okay. We'll have an oxygen here, and we'll have a hydrogen over here. Same idea. The hydrogen has that partial positive charge. Partial negative, partial positive. All right, what happens between this negatively charged oxygen and this positively charged hydrogen? There's an interaction. There's some type of bond. Opposites attract. Now, this interaction will not be a covalent bond. Okay, they're not going to share electrons. There's no sharing of electrons here. What's happening is it's a bond, but it's not a covalent bond. We have a special name for this bond, and we call it a hydrogen bond. Okay? That is a hydrogen bond, where a hydrogen is bonded to something that is very electronegative, oxygen, fluorine, or nitrogen, and it will form a bond between itself and another electronegative species. That is a hydrogen bond. And these hydrogen bonds, again, are very important. These hydrogen bonds hold our DNA together. These hydrogen bonds are important in protein shape. Very important idea here.